Now, how about if we do the same thing? Now, let's do it with the London Eye. The London Eye was a Ferris wheel created to celebrate one of like the quadrennials, some big celebration about the age of England. And the London Eye is this huge one that goes around slowly so you can observe and you pay a lot of money to go on it. But it's a really cool kind of neat thing you do. It's actually doing the same type of idea that we did earlier. Now let's read what it says here. It says, in the London Eye observation wheel, it has a radius of 67.5 meters and takes 30 minutes to make a complete rotation. It says, find the coordinates of the observation car after 6 minutes, round to the nearest tenth. Now there's a few things we're going to assume on this just a little bit. We're going to assume it's going to start horizontally, even though it really starts at its base, but we're just going to do that so we can get the idea of how it works. But we're still going to use my x, and I'm going to use my y axis. Now remember, it's rotating, so I'm going to start here, but it's going to have this radius of 67.5 meters. Okay, so it goes right here. I want to know its coordinates of the observation car after 6 minutes. Now, how much time is that? The full revolution is 30 minutes, so 6 out of 30 is 1/5. So I have to think of what's 1/5 of 360 degrees, because that tells me what portion I'm using, and that's 72 degrees. So I moved 72 degrees. Now I have to solve for my y value and my x coordinate. Well, now what do we have to use if I don't have a 30, 60, 90 or two sides of the triangle? Yeah, we're going to have to use trig. So with that, to solve for x, I'm going to use cosine, because cosine of 72 degrees is going to be x over 67.5 meters. And so I'm solving for x, so I get 67.5 times the cosine of 72 degrees equals x. And they say go to the nearest tenth. So x in this case is going to be approximately 20.9. I'm going to do the same idea for y. I get the sine of 72 degrees, though this time it's going to be y over 67.5. Multiply 67.5 times the sine of 72 degrees equals y. Y is approximately, what do we get here, 64.2. So your ordered pair is 20.9, 64.2. It's just kind of a fun way of doing it. So basically, here would be your ordered pair, 20.9, 64.2. Actually, you're going to use some ideas about this in pre-calculus with your unit circle and things that we have. Now, the next one says show a rotation about the origin by the given angle. Here's the thing, do only arrow notation. I don't need for you to graph it. Graphing, hopefully you guys are kind of getting this down by now. But with this, if I know it's a 90-degree rotation and I'm rotating it that way, I need to remember what my arrow mapping for that is, and that's going to be xy is going to go to a negative yx. So I'm going to use that as my guide with this again. So r is over here at negative 1, 4. So r prime is at negative 4, negative 1. I'm going to do s is at 2, 1. S prime is going to end up being a negative 1, 2. And then I'm going to do the other one over here. And then t, nah, we'll do it like right here. T is over here at 3, negative 3, and t prime is going to end up being 3, 3. So that gives you the idea of where we're working with our primes with this one. And then the same idea, you can do it with 180 degrees. Now, remember with 180 degrees, my x and y's just become their opposites. So my arrow notation for that is negative x, negative y. So that tells me the rule. So r is at negative 1, 4. So r prime is going to be at 1, negative 4. S is at 2, 1. S prime is going to be at negative 2, negative 1. T is at 3, negative 3. And t prime is going to be at negative 3, positive 3. So hopefully that gives you an idea on how to do all of these.